We all know the myth, or the story, of Isaac Newton falling asleep under the apple tree and getting hit on the head with an apple. With any myth, there is a grain of truth. What most likely happened was, as Isaac is walking along minding his own business, he sees an apple tree, and he sees an apple fall from its highest branch and hit the ground. This intrigues him, because he knows that if he holds the apple and he drops it, it hits the ground at a certain speed. If he holds it if he watches it from the top of the tree, it's still falling, but he's not seeing any force being applied. And he figures out that there's an equation for gravity. He just names the force gravity. And originally it's just the equation force equals mass times acceleration. But he goes on to describe universal gravity, which comes out to be the mass of one object times the mass of another object all over the distance between them squared. Now, say we have a basketball and a golf ball sitting in outer space, minding their own business, and we want to measure the gravitational force between them. The mass of a basketball is 0.625 kilograms, and the mass of a golf ball is 0.0459 kilograms. And let's just say, for example, the distance between them is 4 meters. Now, we already know this is going to be a very small number. So simplified, that comes out to be 0.02286, all over 16, which comes out to being 0.0017 newtons. Again, an extremely small force, but a force nonetheless. This is also where the scientist Henry Cavendish comes up with the universal gravitation constant, a force of gravity that is acting on every object in the universe, no matter where they are. And he thinks that force is 6.673 times 10 to the negative 11th. Very small, because it's coming from everywhere in the universe all in one object. Say we want to work with something a little larger, say planets. And the equation will be roughly the same, but we add in the gravitational constant, g. So we plug in 6.673 times 10 to the negative 11th, and we multiply that by the mass of the Earth, which is 5.972 times 10 to the 24th power, and multiply that by the mass of the Earth, which is of the Moon, which is 7.34 times 10 to the 22nd. And we divide that all by the distance between the Earth and the Moon, which has been calculated to be 384,400,000 meters, and we square that. Simplified, this comes out to be 2.927 times 10 to the 37th over 1.477 times 10 to the 17th. But we get a resultant force of about 1.981 times 10 to the 20th. If I was to write that all out, it would be 1981 and add in 17 more zeros. If you want to take a look at other equations I have, try some out for your own. I have about 5 more down in the description. I wish you the best of luck.